And we are live. It's 8:30 Prep. Hello, I am Phil McCaffrey, and we're in the Ambridge studios of 3R Prep, my tutoring company. Today, this is about functions. This whole week is about functions, f of x. We did a little bit of history yesterday. If you remember, they were invented by Leonard Euler. I think it's Euler. I think that's how you say that, is Euler. Today, we're going to go over function translations, something they're called odd and even functions, and then funky functions for the old cherry white. Is it Wild Cherry? Was the band? We have to look that up on the internet. Bonus points for anybody who knows. Play the funky music White Boy from Wild Cherry. They're around here somewhere. And translations. Wait, I did put translations on there. Translating things across the x and y axis. So without any further ado, the parabola dance. Okay, a function written in function symbols like this can move in the xy plane, and this is fair game. It used to be tested quite a bit on the old SAT. It is still tested a little on the ACT, but it's fair game. So it's worth teaching, one, because I love it so much. So my parabola dance song is up, down, left, right, thin, fat, flip. And there's also a spin in there, but we'll just do it. So you can grab a parabola and you can move it up, a function, any type of function. You can move it up, you can move it down, you can move it to the left, you can move it to the right. You can make it thinner or compress it. You can make it fatter or expand it, and you can flip it upside down. And in function notation, there is a way to do each one of these. So let's pick a color for up. Let's do purple is up. So if I move something up, I take the function of x and I add a constant to it. If I add a positive number to the function, the entire function moves up in the xy plane. Higher, the function is y, so y plus c makes sense. If I move the function down, it's f of x minus c. If I move the function to the left, move into red, it is the function of f of x plus c. This is what a lot of students get wrong. If you add a number inside the function moves to the left. If you subtract a number inside the function, it moves to the right. Put a star next to this one. Take notes. You can grab my notes. I post these. These are smartboard notes, and they turn into PDFs, and I post them in the comments. And if you want them, shoot me an email. Peyton, if you want them, you can have them. I already sent these to you, and then I played with them a little bit. To make a function thinner, you multiply it. So this parabola was going to go really thin. You multiply it by a number greater than 1. So multiplying by a number greater than 1. We should have picked a different color. We should have picked blue for that. Let's go with blue. Oh, wait a second, it's not changing colors. If you want to expand the function or make it fatter, you multiply it by a number greater than 0 but less than 1, or a fraction, or you divide by a whole number. So something like 1/2 the function of x. And then lastly, if you want to flip the function, turn it upside down, you can do a negative function of x. It should be noted that flipping a function, you could also compress it and expand it at the same time. So if you multiply by -2, you compress it and flip it. If you multiply by -1/2, you expand it and flip it. So this is the parabola dance, and this is what I've made all of my students do, and I make them do it forever. It's up, down, left, right, thin, fat, flip. That's the parabola dance. I'm going to put that up onto TikTok, and I was going to do it on TikTok with a group of students, and then I thought better of it, and I think I made the wise choice. That is translating a function. All of this is fair game. How does it show up? let's take a look at a real ACT question that says the graph of the function y, because we could put f of x here, is equal to the absolute value of x minus 6 in the standard xy plane. Which of the following transformations, or transformations, when applied to the graph of y equals the absolute value of x, results in the graph of y equals x minus 6? So let's go back a step. If we subtract, we move to the right. And the answer is translate right 6 coordinate units. We certainly know that it's not up or down because that would be f of x, y would equal x plus 6 is moving up 6. Absolute value of x minus 6 is moving down. So up and down is wrong. And then reflect across the line x equals 6 is here is the line x equals 0. Here is the line x equals 6. That's a whole nother question. It's just a completely wrong answer. But most students get this wrong because of subtracting. They say it moves it to the left, and that's adding. All right, here is a off of the current ACT practice test. Let's make that a little bit bigger so you can see it. That's hard to read on the screen. Let's make that bigger. Sorry about that. It says the functions y equals the sine of x and y equals the sine of the quantity x plus a plus b. Do the dance, said Teo. Do the dance. Y equals x plus a plus b for constants a and b are graphed in the standard xy coordinate plane. The functions have the same maximum value, which is a clue here. One of the following statements about the values of a and b is true. Which statement is it? So we are transforming this function. So here is the parent function, y equals the sine of x. So you notice it moves left and right, but with a sine wave, you're not really sure if I'm moving it way to the right or way to the left. So a moves it horizontally. If you watch my video on trigonometric functions, this will be covered on it. We don't know if a is greater than 0 or less than 0. It's one way or the other. It's certainly not 0, so C is wrong. But what we have here is, did we move the function up or down? And if you recall from trigonometric functions, and you may not recall, this is the amplitude. And the amplitude is the coefficient in front of it. Right here we have an amplitude of 1. The amplitude is the same. So it has the same maximum value, meaning it also has the same minimum value. What does that mean? It didn't move at all. Therefore, the correct answer is that B is equal to 0. You don't have to know trig functions to know transformations, so you know that it didn't move up or down, so B is 0. Students get this question wrong about 85 to 90% of the time because they just don't know what to do. But when I ask them what happens when you add something to a function, you say it moves up. Did this function move up? It has the same maximum value. No. And it's that simple. All right. Funky functions. Play that funky music, white boy. I used to love funky functions on the old SAT. They dropped it. And that is putting some symbol in for a math function. The ACT still has this. This is an official practice test. And they've revived it on the very next question, as we'll see. Charles defined a new operation, diamond, on pairs of ordered pairs of integers as follows: a comma b, diamond, c comma d is equal to a times c plus b times d, all divided by a times b minus c times d. What do? Simon says, just simply plug in what the numbers are. So I'm going to put in here as A, B, C, and D. You match the numbers they give you with the definition of the function. So let's put this in. A is 2, C is 3, plus B is 1, and D is 4. I'm going to divide that whole thing by A is 2, B is 1, minus C is 3 times 4. Now let's see me do some arithmetic live on YouTube. Ready? 2 times 3 is 6, plus 4 is equal to 10. And 2 times 1 is 2, minus 3 times 4 is 12. God, I had to hesitate. Oh boy. I'm not as tired as I was yesterday, Peyton, if you're watching. And 2 minus 12 is negative 10. And 10 over negative 10 gives me an answer of negative 1. Good thing I practiced this problem. Here's the one that just showed up recently. Let's blow that up a little bit. It's a little small. This is off of a current test. Sorry that it's so scraggly, but what we have to do to steal these is make a photocopy of a newsprint and then scan it in for the PDF. And it says, Carrie is inventing a new notation in math. So this one came up fairly recently. She has decided to use n down arrow to denote the sum of the first n positive integers. For example, 5 and down arrow means 5 plus 4 plus 3 plus 2 plus 1. Carrie has written 3 statements that she is investigating as possible properties of n down arrow. Well, let's use an example. Let's use 3 down arrow, and that's going to equal 3 plus 2 plus 1, which equals 6. So, n down arrow, 3 down, plus n plus 1, which would be 3 plus 1 is 4, is equal to 4 down arrow, which would be 10. That's true. 1 is true. I hate the Roman numeral questions 1, 2, 3 because you have to answer 3 questions. I always say these are 3 questions in one, and it's a number 58. This is definitely one I would do last because it takes so much time. And when you come down in here, 1 is correct, so none is wrong. 2 and 3 are absolutely wrong. And then here's my rule of thumb. On Roman numeral questions 1, 2, and 3, like these are Roman numerals in case you forgot what Roman numerals are. It is extremely rare that all 3 of them are correct. If I had to guess at this point and I was running out of time, I would guess F, 1 only. But let's check out 2 and 3 to see if it's wrong. So 3 down arrow plus 3 down arrow is 6 plus 6, which equals 12. Is that equal to 2 times n, which would be 6 down arrow? Well, what we have to do is all we have to determine is if 2 is right or wrong, because if 2 is wrong, 3 is absolutely wrong. So this is 6 plus 5 plus 4 plus 3 plus 2 plus 1. One of the fun ways to add up strings of integers is to pick the ends. 6 plus 1 is 7. 2 plus 5 is 7. 3 plus 4 is 7. The answer is 21. Is 12 equal to 21? Nope. 2 is wrong. The correct answer is 1 only. Let's do answer choice 3 just for fun because we're on YouTube, and that is n squared down arrow, which we're going to do. Remember, n we're using is 3. So this is going to be 9 down arrow is equal to 3 down arrow squared. And so this is 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. 3 squared, we already know what 3 squared is. 3 down arrow was 6, squared is 36. So this whole mess has to equal 36. Let's use my little trick. 1 plus 9 is 10. 2 plus 8 is 10. 3 plus 7 is 10. 6 plus 4 plus 6 is 10. That's 40. it's already not 36. So this answer is 45. 36 does not equal 45. So this is a funky function that you have to figure out. And by playing the game in Roman numerals, the one thing that I would always go with is it's usually two of the three. The SAT was about 60-70% that 2 and 3 only. But this answer choice is appropriately F. All right, what do we have next? Even and odd functions. Let's do the questions. I should blow this up. I did this morning at home. It's too small. What is an even function? The graph of the trigonometric function y equals 2 times the cosine of 1/2 x is shown below. This function is, and here are all the answer choices, even, odd, neither even or odd, the inverse of a cotangent function, and undefined at x equals pi. Dudes, here is x equals pi. It is defined. Pi is where x is going to equal 0. All right, so let's take a look at it. An even function is where the function of x is equal to the function of its opposite. So if I picked pi, it's 0, and I picked pi over here, would it be 0? If I picked 2, is it even at 2? So let's pick blue. Is this an even line? That is an even function. The answer here is that it's even, because an odd function, if the 2 was up here, its opposite would be down here. So evens, the functions, the output are the same. Odds, the functions are opposite. So where does this come from? Interestingly enough, a parabola is an even function. And a cubic, that's a really bad cubic. I'll show you in the next one. That was a terrible cubic function. All right, a function f is an odd function if and only if the function of negative x is equal to the negative of f of x for every value of x in the domain of f. One of the functions graphed in the standard xy plane, in the standard xy coordinate plane, is an odd function. Which one is it? The answer is E. This is a cubic function, or it's an odd function. It could be x to the 5th or x to the 7th. And to show you that, 2 cubed, let's see, how does this work? The function, so 2 cubed is 8. So the function of negative 2 is equal to the negative of the function of 2. Okay, so negative 2 cubed gives me negative 8, and that is equal to negative 8. That works. That's why a cubic function is odd. And you could play with these other ones. None of them work. None of them are, this one is even. This is a hyperbola that has nothing to do with it. This is the line. Lines are neither even or odd. And I haven't looked at this weird absolute value one. It does kind of look even, but E is the only odd answer. All right. Reflection. That's the word I was looking for, reflection. I should have set this up a little bit better. All right, on reflection. In the standard xy coordinate plane, A prime is the image resulting from the reflection of the point A 2, negative 3 across the y-axis. What is the coordinates of A prime? So let's take the xy plane, and A is 2, negative 3. And we're reflecting it across the y-axis. So here is the y-axis. This would be the x-axis. When you reflect across the y-axis, the y stays the same. So this becomes the point negative 2, negative 3. Let's stop right there and see if there's an answer choice negative 2, negative 3. There is. Answer choice B. Is there an answer to positive 3? There certainly is. That's D. D is a reflection across the x-axis. There is the famous SAT one where they have a point and they reflect it across the line. I got to dig that bad boy out because that's still fair game and kind of fun, and you have to play with it a little bit. But I haven't seen that on the ACT. Not too bad. 20 minutes for a session on weird functions. Tomorrow is translations. Today was translations. Tomorrow is functions on the ACT, and Thursday is functions on the SAT. I'm Phil McCaffrey. Thanks for watching 8:30 Prep. I'll see you tomorrow.